Hello friends, earlier we have talked about in video number 1 about the stoichiometry and volumetric analysis. This is our video number 2 and we are going to talking about the chemical equilibrium and chemical kinetics. Now it will be a short video, so watch till end. Now first of all, chemical equilibrium. We are going to talk about the chemical equilibrium constant. Equilibrium constant K equivalent is equal to product by reactant, means means active mass of product by active mass of reactant. In the reaction A, B, B, C, C, D, D, C power stoichiometric coefficient C, D power coefficient D, A power A, and B power B. This means for the equivalent chemical equivalent constant, chemical equilibrium constant. Okay, the active mass or molar concentration is equal to number of moles by volume liter. Active mass or molar concentration is equal to number of moles by volume liter. Concentration, active mass, mole per liter. Mole is equal to normal number of moles. Molarity is equal to number of moles per unit liter. All the unit are same. Concentration, which means active mass, which means moles per liter, which means molarity. Molarity means number of moles per unit liter. Then after equivalent constant is equal to forward constant by backward constant. Forward by backward. Now, number of moles N is equal to concentration number of moles. N is equal to molarity times volume liter, and number of millimoles is equal to molarity into volume ml. Kp is equal to Kc R to the power del N. Kp is equal to Kc R to the power del N. It is the BBI formula. Kp is equal to Kc R to the power del N. Okay. Now del N means number of moles of product minus number of moles of reactant. Now P minus R. P minus R. P means C plus D and R means A plus B. If the del N value is negative, means the number of moles of reactant is more than number of moles of product. If del N value is negative, then Kp is less than Kc. Then Kp is less than Kc, and atomic, and then the unit of Kp is equal to atmospheric pressure for power minus del N, and Kc mole per liter power minus del N. If number of moles of product is greater than the number of moles of reactant, then del N should be positive. Then let's become positive, and Kp is greater than Kc. The number of unit of Kp is equal to atmospheric pressure power del N. Kc is equal to mole per liter power del N. For this is important for condition for Kc. Condition for Kc, if the reaction is reversed, means this goes this side, this goes this side, then we should take the reciprocal. Then if the multiplied by 2, we should square by 2 for the constant. We should square the constant by 2. If the reaction is divided by 2, we should put their square root of the chemical constant. Now Kc only depends upon temperature. Kc does not depend on any what, only on the temperature. Log K2 by K1 is equal to del N 2.303 times 1 by T1 minus 1 by T2. K is inversely proportional to 1 by T. If K increases for endothermic, K increases with increase in temperature. For K decreases with decrease in temperature, and for exothermic, K increases with decrease in temperature, and K decreases with increase in temperature. Chemical equilibrium. Kc does not depend upon concentration, pressure, catalytic addition of inert gas nature, and number of steps of reaction. Kc only depends on the temperature. If Kp and Kc value is large, then the reaction will go the further. Okay, then the tendency of forward reaction increases, and stability of product increases, and unstability of reactant increases. If Kp and Kc value increases, the number of then the reaction will go further to complete, and the tendency of forward reaction increases, and the stability of product increases, and unstability of reactant increases. Now if we have given so small reactions to A, B to C, and C to D, and we have to conclude the constant for direct A to D, then we can multiply the simultaneous constant. Now reaction quotient. If the reaction quotient is greater than Kc, then the reaction is backward. If the reaction quotient is equal to Kc, then the reaction is at equilibrium. If the reaction quotient is less than Kc, then the reaction is forward. And reaction quotient means the determination of chemical equivalent at any condition, and then after the chemical equivalent is the determination at equilibrium conditions only. Now in the reaction, this is an example. H2 plus I2 gives 2HI where A, B and 0. Then at initial condition no product is formed, so atomic so active mass is 0. For H2 the active mass is A, and for I2 the active mass is B. But after the reaction, the 2 moles of HI is formed, so 2 X and B minus X and A minus X. For the active mass, mole per liter, so every number of moles is divided by volume, and for the Kc, number of mole concentration of product by number of molar concentration of reactant. And then after the solution, this is our next solution. A plus 5B gives 3C plus 2D. This okay. And now Le-Chatelier's principle. When we increase the concentration, always suppose that we are increasing the concentration of the reactants, and if we increase the concentration, the reaction always goes forward direction. If we decrease the concentration, the reaction will go the backward. If the pressure increases, then the reaction will go at that condition. Okay, if we increase the pressure, then the reaction will go to that side where the number of moles is less. Moves where number of moles is less. If the pressure increases, then moves where number of moles is less. If the pressure is decreased, then moves where number of moles is more. If the temperature is increased, then moves where heat is absent, and if the temperature is decreased, then moves where heat is present. If the temperature increases, then moves where heat is absent. If the temperature decreases, then moves where heat is present. And diluents is negative than exothermic, diluents is positive than endothermic, chemical or dynamic equilibrium. All the for the reversible reactions, gives free energy is equal to 0, and for the irreversible reaction gives free energy less than 0. It means del G is equal to negative, which is spontaneous, and all the reversible reactions are chemical or dynamic equilibrium, which is under constant temperature and pressure. Effects of factors on equilibrium state. Not only concentration, pressure, and temperature, but there are 2 more factors which also determines the equilibrium state, that the catalyst and inert gases. No effect, but equilibrium attains quickly. Catalyst does not take part in the reaction, but have the reaction to gain the product quickly. Now for the inert gas, if we add the inert gas, at constant volume, then there will be no change. But if we add the inert gas at constant pressure, then the reaction favors forward reaction. Then addition of inert gas at constant pressure favors forward reaction when del N is greater than 0, and backward reaction when del N is less than 0. It means if at the constant pressure भएपछि इनर्ट ग्यास एड गर्दा जहाँ नम्बर अफ मोल्स बढी हुन्छ रियाक्सन त्यही जान्छ. बुझ्नुभयो? म एकचोटि अझै बुझाउँछु है. ल हेर्नु त, यदि प्रेसर कन्स्ट्यान्ट भएपछि इनर्ट ग्यास हामीले एड गर्दा के हुन्छ भन्दाखेरि जहाँ नम्बर अफ मोल्स बढी हुन्छ नि रियाक्सन त्यहीँतिर सिफ्ट हुन्छ. यो कसले बनेको भन्दाखेरि एट कन्स्ट्यान्ट प्रेसर. अहिले म साइन्टिस्टको नाम त याद आएको छैन, म पछि भन्छु है. ल N2 plus O2 gives 2 NO minus 0. This is the very confusing term, so I have written it for you. Like N2O2 gives 2 NO. There is diluent sign. Diluent is not given, but diluent is given. There is not given. So we should get here. डाइरेक्टली लाइक देयर माइनस यो यहाँ ल्याउँछ भने के हुन्छ प्लस हुन्छ भने हिट यहाँबाट दियो हिट कहाँबाट दियो रियाक्टेन्ट साइडबाट दियो त्यसैको लागि यो के भयो इन्डोथर्मिक भयो त इन्डोथर्मिक भएपछि हामीलाई प्रडक्ट बनाउनको लागि हिट के गर्नुपर्छ बढाउनु पर्छ कि घटाउनु पर्छ ल हिट के गर्नुपर्छ भन्दाखेरि घटाउनु पर्छ किनभने इफ यु इन्क्रिज द टेम्परेचर द रियाक्सन शिफ्ट टुवर्ड्स नम्बर अफ मोल्स इज सरी इफ यु इन्क्रिज द टेम्परेचर the temperature shifts where heat is absent, so heat is absent on the product side. So if we increase the temperature the more 2n is found. Got it? Yeah. Now in the reaction of in the manufacture of ammonia by Born-Haber process, there is given del H is equal to negative. Negative means exothermic reaction, so heat is present on the product side, so we should keep less heat. Got it? Okay ल डेल भनेर दिएको छ भने डेल एच इक्वल टु नेगेटिभ एक्जोथर्मिक र डेल एच इक्वल टु पोजिटिभ इन्डोथर्मिक भनेर बुझ्ने डाइरेक्ट दिएको छ भने डाइरेक्ट युज गर्ने नाउ द्याट्स अल फर केमिकल इक्विलिब्रियम नाउ वी आर इन्टरिङ इन्टु केमिकल काइनेटिक्स means rate of reaction is equal to change of concentration of reactant or product by time. The unit of rate of reaction is mole per liter per second. Rate constant R is equal to Ka power del N. Now unit of rate constant K is equal to mole per liter 1 minus n and s to the power minus 1. It is the asked question, so we should look after it. Now unit of K is equal to mole per liter power 1 minus n. Yes, for the zero reaction n becomes 0 and mole per liter per second. For the first n becomes 1 minus 1 0, the whole value become 1 and only the unit of K is s minus 1. So now together same as for the okay a plus b given c, then the then minus time del a by dt is equal to minus del b by dt, means a and b are disappearing, whereas c is appearing, c is forming and a and b are deforming. Okay, now rate is equal to Ka to the power m b to the power n. Now order is the sum of powers which are associated with the coefficient of A and B. So sum of power order is equal to sum of power m plus n, which can be positive, negative or 0. Once again I am telling you the order is the sum of powers. Once again I am telling you the others are the sum of the powers m plus n, which can be positive, negative or 0, and the molecularity is the sum of stoichiometric coefficient 2 plus 1 is equal to 3, which can never be 0 or negative or fraction. It is always in positive. Now molecularity is the rate determining aspect. Molecularity is the rate determining step for any reaction, as is the slowest step. Now rate of reaction increases with increase in temperature. For every reaction, but for the reaction 2NO plus O2 gives 2NO2, rate of reaction decreases slightly with increase in temperature. It is the exception, we can remember it. Now rate of reaction increases with the increase in temperature, but 2NO gives 2NO2, rate of reaction decreases with increase in temperature. Now the factor affecting rate of reaction, we can remember it by mnemonics CAT. C stands for concentration of reaction, and A for area, which is inversely proportional to the size of particles, and CAT means catalyst which lowers activation energy. Okay, for concentration of reactant, concentration of gas means concentration of gas is more than liquid is more than solid. Then after temperature or number of collision, for 10 degree rise in temperature, the rate of reaction is shifted by 2 times or 3 times. Okay, then catalyst lowers activation energy. Now factors affecting rate constant are NTC. We should memorize it by NTC, nature of reactant, temperature and catalyst, but not concentration. Means nature of reactant, temperature and catalyst affect rate constant, whereas CAT affect rate of reaction. Now pseudo first order reaction order is equal to 1, molecularity is more than 1. It is known as pseudo first order reaction. We should remember the examples, it's very important, like inversion of sucrose is also a pseudo first order reaction. Hydrolysis of organic collide and acidified hydrolysis of ester. Acidified hydrolysis of ester, inversion of sucrose are the examples of pseudo first order reaction. Now zero order reaction for order is equal to 0, rate is equal to k. Rate of reaction is independent on the concentration of reaction. Rate of reaction is independent on the concentration of reaction, like rate of reaction is equal to k power 0, then is equal to k times 1 is equal to k, independent of concentration of reactants. Examples are reaction and presence of light and photochemical reaction, then after dissociation of metal surface iodination of acetone. X is equal to kt. X के हुन्छ भन्दाखेरि केटी नै हुन्छ, x x सधैँ के हुन्छ केटी हुन्छ. X is equal to kt for T half life, or X is equal to a by 2, so T half life is equal to a by 2k. Now for the T half life, directly proportional to the a means concentration to the power 1 minus n. For zero order T half life is directly proportional to a, and for the first order half life is independent of concentration of reactant. For the second order T half life is directly proportional to power minus n, and so on. Okay. For first order reaction, K is equal to 2.303 by T log A by A minus X. For a first order reaction, K is equal to 2.303 by T. For first order reaction, M plus N should be 1, and K is equal to 2.303 by T log A by A minus X. T half life is equal to 0.693 by K. Radioactive decay. The main example is radioactive decay. Decomposition of NH4 NH3 and hydrolysis of ethyl acetate. Now second order reaction. Hydrolysis of ester by alkali. In the basic media, hydrolysis of ester in acidic medium is the example of pseudo first molar reaction. Pseudo first order reaction, acidic hydrolysis of ester, and second order reaction, basic hydrolysis of ester. Okay. Now conversion of ozone into oxygen, it also has second order reaction. As you have further study 1 by 8 times divided E, this we cannot know. For the zero order reaction, rate of reaction is independent of the initial concentration. For first order T half life is independent of the initial concentration. Positive catalyst decreases activation energy, negative catalyst increases activation energy. Rate of reaction, change in rate is equal to change in concentration to the power order. Change in rate is equal to change in concentration to the power order. Now order of reaction. For if the concentration of reactant double. For zero order X in place of X when we write 0, then it is independent on the concentration. For the zero order reaction, concentration of reactant double or triple, then rate of reaction is equal to same. For first order reaction, rate of reaction double, rate of reaction double, same square, double rate of reaction 4 times, triple rate of reaction 9 times, double rate of reaction 8 times, cube. Now order निकाल्नको लागि IPL याद गर्ने, means 1 plus liter in the power of liter. When we add 1 in the power of liter, liter को power मा 1 plus गरेपछि के आउँछ भन्दाखेरि order आउँछ. Simple. Now in this it is the value for rate constant. Liter power minus 2, when we add plus 1 it becomes minus 1. Then minus 1 is the order of this chemical constant. Now there are two terms, activation energy and threshold energy. Now activation energy is the minimum additional energy. It is the minimum energy required to initiate a chemical reaction. Activation energy is the minimum energy required to initiate a chemical reaction. In the same way, threshold energy is the total minimum energy required for the reactants to reach threshold, minimum amount of energy. Now in the both the threshold and activation energy are minimum energy. Activation energy is the minimum additional energy, whereas threshold energy is the minimum amount of energy which is required to initiate a chemical reaction. Or threshold energy is the total minimum energy required by reactants to reach threshold. This much for now. In this video we have talked about the chemical equilibrium and equilibrium constant. This much for now. Now we will talk about the electrochemistry in the next video. Thank you for watching.